This is the 2019 Level 1 Mechanics exam, question 3. Sweet. Parachutist with a total mass of 63 kilograms jumps from a plane. Show that the parachutist's gravitational potential energy when the plane is 3,500 meters above sea level is 2,205,000 joules. So, in your formula sheet, if we skip to the front, we have gravitational potential energy, so EP, is equal to mass times gravity, which is given to you as 10 Newton kilograms, or newtons per kilogram, times change in height. And this is the kinetic energy, so this is EK, meaning kinetic. That's half mass times velocity squared, or just speed. Right, so we're going to write, this is a show question, so first we need to write the formula. EP equals mass times gravity times change in height, and that is equal to 63 times 10 times 3,500. So you have to have the equation, the substitution, and then the answer, which gives you 2,205,000. And we'll just write that in. 2 million, we can put commas if we want, 205,000. Right, joules, so we need to put the units as well. And then down the bottom, we'll just leave it at that, that's fine. Right, the parachutist falls a distance of 450 meters during the first 4.49 seconds. Calculate the average speed of the parachutist during this time. So the average speed would happen halfway through the flight. So that's one way you could sort of work it out. But you can also just go total distance over total time would give you average speed. So in your formula, I'll show you where this formula is. Where is it? It is velocity equals, where is it? Change in distance over change in time. So we're going to go velocity equals change in distance over change in time, and that is going to equal to 450 divided by 9.49, and that is going to be equal to 47.418 meters per second. So, right, 47.418 meters per second, because that's the units for velocity. And then down the bottom, we're going to put velocity or speed. They're synonyms in level 1 and level 2, they're a little bit different. And that is going to be equal to, round this to 3, or should really be rounded to 2, but round it to 3 significant figures, which means it's going to be 47.4 meters per second. When you do level 1, you should just have 3 numbers. 3 numbers is probably the easiest way to explain it. Right, next question. Explain the vertical motion of the parachutist immediately after jumping out of the plane before the parachute opens. So just immediately after means they've just launched themselves out and they haven't really sped up much yet. In your answer, you should describe the vertical motion of the parachute. So what you'd say is they're accelerating under the force, or they're accelerating due to gravity. So they'll be accelerating, they'll be speeding up. Describe the net force and state whether the forces are balanced or unbalanced. The net vertical force will be gravity acting downwards. If it's just immediately after, I would expect it to be unbalanced, because by then they haven't sped up enough for air resistance to be much of an issue. And then explain how the net vertical force affects the motion. It'll cause the parachuter to accelerate up and continuating. Like accelerating downwards, I should say, because it's not falling down, until they hit terminal velocity, or until such time that air resistance is so great that the force of air resistance upwards balances the gravitational force downwards, and then they hit terminal velocity. In other words, just go constant speed. So I'll pause it, write out a full answer, and yeah. Right, so I said when the parachute jumps out, he will accelerate downwards due to gravity. His vertical velocity downwards will increase because he's jumping out of a plane. Assuming he just jumped out, air resistance will be small, so forces will be unbalanced. That's this massive assumption I'm making here. And if net, so total force, net force, will act downwards. And now you need to say what the net force is. So the net vertical force downwards is due to the weight force. You could say gravitational force, but weight force is slightly more succinct, which accelerates the person downwards. I should say that. even though I already sort of said it like twice. And then I've chucked in just like a wee force diagram, like all free body diagrams, but whatever. And I've got air resistance pointing up, which is obviously smaller than the weight force pointing down. When it hits terminal velocity, or after a significant amount of time, this air resistance grows until it's the same size arrow as the weight force, which means there's no acceleration, which means it'll just continue at a constant speed or velocity, either or. You can say either word. This question, in terms of how it's written, is poor. I'm going to critique it now. This should be first, because the net force causes a motion. Then you should describe the net force, and then this should be last. So in your answer, maybe you should have, I answered it how typically you should answer, by addressing each bullet point, just so it's cohesive to understand. But if I was to answer this properly, with a full understanding, you should answer with this first, then that, and have it in the opposite order, because the net force is what causes the acceleration, and then the acceleration is what causes the change in speed. But this is just how you can do it if you're just trying to like answer each bullet point like easier. I don't know. Right, during the 450 meter fall, the parachutist's gravitational potential energy was reduced by 283,500 joules. Calculate the parachutist's downward speed at 450 meters. Oh, he only jumped for 450 meters. Assuming energy is conserved. So let's read this again. During his fall, the gravitational potential energy was reduced by that. Calculate the parachute downward speed at 400. Man, this is crazy confusing. Yeah, this doesn't really make sense, because it assumes he hasn't pulled his parachute, even though he's a parachutist. So this is just assuming he's fallen 450 meters and went smack onto the ground. So what it means is all this energy was directly converted into speed. So you have a formula in your front formula sheet. I'll find it now. Where is it? There it is. The kinetic energy formula, half mv squared. So we'll just write that down. Kinetic energy, EK, is equal to half mass times velocity squared. So we need to rearrange to find his vertical speed. And this is equal to the potential energy. This is because converting potential energy to kinetic energy, which would have been also equal to mass times gravity times height. But they've just given us the energy as a value, so we can just substitute in for here. So we need to rearrange velocity. So how are we going to do that? I'll try and do it in as many steps as I can. So we'll times both sides by 2. So I can get rid of, because I want to isolate this v squared. So if I times half by 2, I get 2 over 2, which is 1. And 1 times m times v is the same as mass times velocity. So if I times both sides by 2, I get 2 times the potential energy. Because you got to, and I'll just forget about this, because this is equal to that. And that is equal to the mass times the velocity squared. Now what do? I want to isolate the velocity, so I go, well, how do I undo mass times velocity? I divide both sides by mass. So I go 2 potential energy, 2 times potential energy divided by the mass, and that is equal to, so mass just over here, mass divided by mass is equal to 1, or anything divided by the same thing is equal to 1. So I get is equal to 1 times v squared, and you can see 1 times v squared is just v squared. And now how do I undo this v squared? So the opposite of squared is square root. So I get the square root of everything, 2 EP divided by the mass is equal to the velocity, and that is equal to square root 2 times, put the whole number in, 283,500 divided by, what's his mass, 63 kilograms, I'm pretty sure. 63, yeah, 63. And that is going to be equal to 94.86 meters per second. So I'll write that in, 94.86 meters per second, and then we'll just check down here. V is equal to, round it up to 95, because that's 2SF. That's 2SF. But you don't have to worry too much. Just write the full, always write the full unrounded answer, and then you can round it to whatever you like. If you don't round it to like 1 decimal place or whatever, just round it to like 2 numbers, meters per second, and they'll mark the most correct one. You'd hope they would anyway. Right, just some tips when you do this on your calculator. Do the top line first, and then hit answer, or to do the stuff inside the inside the square root, and then you can go square root, so shift square root on this calculator, and then go shift answer, like press shift, then go answer, and that'll use a previous answer, and then you can do that there. It's a bit easier, or just use heaps and heaps of brackets.